Hello everyone, this is Shreya and thank you for being here. Today I'll be walking you through an introduction to database management systems, commonly known as DBMS. This is a fundamental concept in the field of information technology, and understanding it is essential for anyone working with data or pursuing a career in computer science, software development, or IT management. In this session, we'll explore what a DBMS is, its key functions, types, and its importance in our digital world. What does DBMS stand for? DBMS stands for Database Management System. Is software that enables us to create, manage, and manipulate databases. In simple terms, it provides a systematic and efficient way of storing, organizing, and retrieving and managing data efficiently. Rather than storing data in files or spreadsheets where it's harder to organize and retrieve efficiently, DBMS lets us store it in a structured format. Think about how much data we interact with every day, whether it's on social media platforms, e commerce, websites, or banking applications. All this data needs to be stored and accessed quickly and securely. And that's exactly where a DBMS comes in. It acts as an interface between users and databases, allowing both users and software applications to interact with data using structured methods, typically through a language like SQL, which is structured query language. Now, now let us see why DBMS is essential. Now you might be wondering why not just use spreadsheets or basic files to store data? DBMS brings a lot more to the table. First, it reduces data redundancy, which is the unnecessary repetition of data. Without a proper management system, you might have the same information stored in multiple places, leading to confusion and inconsistencies. Second, it ensures data integrity, meaning that the data remains accurate and consistent over its entire life cycle. This is critical for making informed decisions. Third, a DBMS provides data security, controlling who can access or modify the data. It supports multi user environments, meaning several users can access and work on the data at the same time without interference. Finally, it simplifies complex data operations. For example, you can retrieve very specific information quickly with just a single query rather than manually sitting through data files. Now let's see key functions of a DBMS. Let's dive deeper into the core functions of a DBMS. Data storage and retrieval. This is the primary function. A DBMS stores data in a structured way and retrieves it efficiently, where its customer records, financial transactions, or inventory lists. The system allows quick access and management. Data manipulation. A DBMS isn't just for storing data, it also allows users to insert new data, update existing data, delete outdated records, and run queries to fetch specific information. Data security. Through user roles and permissions, a DBMS ensures that only authorized users can access or modify certain data. For example, a finance officer might be able to view financial reports but not change salary details. Data integrity. This ensures the correctness and consistency of data. A DBMS enforces rules such as ensuring that no two users have the same ID or that an entered email address follows the correct format. Backup and recovery. If something goes wrong, like a system crash or accidental deletion, a DBMS provides mechanisms to back up the data and recover it without loss. These functions make a DBMS essential for any organization that relies on data driven operations. Examples of DBMS. There are several popular DBMSs in use today, and they come in both commercial and open source varieties. Oracle database, known for its high performance and used widely in enterprise applications. MySQL, an open source option commonly used in web applications and small to medium businesses. Microsoft SQL Server, widely used in Windows based environments, especially in corporate settings. PostgreSQL, an advanced open source DBMS known for its compliance with standards and complex queries. MongoDB, a popular NoSQL database used for handling unstructured or semi structured data, especially in modern web applications. Each of the systems have different needs and scales depending on the complexity and size of data operations. Oracle, MySQL, Microsoft SQL Server, and PostgreSQL Server come under RDBMS, which is nothing but relational data management system, and MongoDB comes under NoSQL database management systems. Now let's see about types of database management system. There are different types of database management system because not all data fits neatly into the same model. Relational database model system. This is the most widely used type. It organizes data in tables with rows and columns, much like a spreadsheet but with much more power behind the scenes. Examples include MySQL, Oracle, and SQL Server. Hierarchical DBMS. Here data is structured in a tree-like format. It's suitable for applications with a clear hierarchy, such as organization, charts, or file systems. However, it's not very flexible when relationships between data are more complex. Network DBMS. In this model, data is organized in a graph structure that allows more complex relationships like many to many connections. It's more flexible than the hierarchical model but harder to implement and maintain. Object oriented DBMS. As the name suggests, it stores data in the form of objects just like in object oriented programming. This type is useful for applications where data and its behavior need to be bundled together. NoSQL DBMS. These are designed for handling large volumes of unstructured or semi structured data, especially in real time web applications. They don't use the traditional table based format and are suitable for things like big data and real time analytics. MongoDB is a prime example. Each type has its strengths and it's suited for different kinds of data and application requirements. Let's talk about importance of DBMS. To wrap up, let's revisit why DBMS is so important in today's data-centric world. It reduces data redundancy and maintains consistency, which is essential for reliability. It ensures security, controlling access, and preventing unauthorized use. It simplifies data operations, making it easier for user to insert, update, and retrieve information without deep technical knowledge. It supports multi-user environments, enabling team collaboration and real-time access. Most importantly, it empowers better decision making by keeping data organized, accurate, and easily accessible. Whether you are managing customer data, financial records, or scientific research, a DBMS is the backbone of efficient and effective data management. Thank you for your attention. I hope this introduction has helped you understand what a database management system is, how it works, and why it's such a vital tool in modern computing. Hope you have a good day. Thank you.